Okie dokie. So we started solving equations on a warm-up with trigonometric functions. And here we're going to look at some of these inverse trig equations. And then today we're going to look at and start solving trig equations. Okay. I did get the section, but I forgot to send it to y'all. So I'll probably do that in class today. So we're right now chapter 7, section 3, which is normally at the end of the chapter, but this version they put the equations at the beginning of the chapter. So that's why I skipped it. And we'll probably continue this on Friday. What we're going to start today. Okay, so basically, notice the little -1 symbol. That's not an exponent in this case. That's a way of indicating this is the inverse sine function, and this is the inverse cosine function. So those are not exponents. They're symbolically representing the inverse functions. Now, what people do is they'll ignore that and they'll write these equations with the arc word. And so that way you don't get that misconception. And remember arc because the output of the inverse is an angle, which in radians is the arc length of a unit circle. So this is often another way that you'll see this. Okay. So if we want to solve this, what does this mean? Well, this is giving us the ratio 2x, and we already know where it occurs based upon the angle pi over 4. So we're told that the sine of some ratio is going to occur at pi over 4. So we already know where that is. Right? And we already know what pi over 4's sine ratio is. It's root 2 over 2. Okay, so 2x equals root 2 over 2. And then you solve that. So that's just thinking about these quantities, understanding that the input to the inverse is a ratio, the output is an angle location. And if you remember with the sine, the output's going to be in the first and fourth quadrant regions, if you remember the principal values. Another way of thinking about this one, okay, is let's switch to the reverse function. Just like if we had x squared equal to 9, the reverse function would be the square root. And so we can take the square root of the other side. We switch to the reverse function. Now people say you're square rooting both sides, and that's true. But essentially you're just switching from the function to the inverse when you solve this. That's really basically what's going on. So we can do that with this problem. All right, so let's put the sine function on the other side. Let's switch to the reverse. Right, and then now this is a little more methodical. We already solved this problem, or at least almost. All right, so then, well, at pi over 4, the sine ratios are root 2 over 2. So we still get to the same place. Again, just another way of thinking about it. So that way we enter the concept from the front door, and then we sneak around the back, jump over the dogs, and try not to get bitten, and go through the back door. And now we have two ways of looking at the same concept. Now it's a little harder for the second one because we got an inverse function equal to an inverse function. Well, this is where the concept's going to be a lot better the way we thought about this the first time. Now there are techniques, and we're going to get to those probably in the future, but today we'll just think about what this means. This is saying the angle from the sine function that had a ratio of 2x is the same angle from the cosine function that had a ratio of x. That's what that's saying. So whatever angle this is the same as the angle on the right side. The only thing we know about the ratios is that the sine ratio is doubled the cosine ratio wherever this occurs. So we're looking for in the unit circle. Well, if we assume x is positive, then where in the unit circle is the sine ratio going to be double the cosine ratio? Right? So 1x, 2x. And again, that's if we assume x is positive for simplicity. Okay, so how can we solve this? Well, let's go ahead and model the problem. All right, so here's our triangle, wherever it might have rotated to, and there might be another possible solution, right? One doubled than the other, so probably when they're both negative would be another possible solution. All right, so I'm going to make the hypotenuse 1 because that's true in the unit circle. Well, the sine would be the opposite over the 1. We want that to be 2x. And the cosine would be the adjacent over the 1, and we want that to be x. And lo and behold, we have our fabulous theorem that we use over and over again. That's the theorem. And you just solve that and you get the solution. Okay, so I'm going to pause, and then I'll tell you what you should have gotten for that one. Okay, again, don't forget this is going to become 4x squared, right? 4x squared plus x squared is 5x squared, right? So what you should get, and I'm going to leave this unrationalized, 1 over root 5, and then this would be double that, 2 over root 5. Now, we don't even need to know precisely what the angle is because we were given enough information based upon the inverse trig function. If the two functions are outputting the same angle, that's what that means when they equal. And the sine ratio was 2x and the cosine ratio is x. So if we use a right triangle to model the problem, you can get a Pythagorean theorem and solve. But it's an interesting exercise. What angle would that be? Okay, so notice the x came from the cosine, so the cosine at that angle would have been the x, and the 2x came from the sine, so the sine at that angle would have been 2x. Right, so if we go ahead and take advantage of the huge conglomerate monopoly company called Google, if you just type calculator, it'll give you this. Now, if you want to use the inverse trig functions, you got to do the inverse here, and it'll give you those options. And then radians is highlighted, and if we wanted degrees, which I'm going to do degrees just for the sake of it, we'll highlight that. All right, so let's test this. The cosine ratio was 1 over root 5. So what's the inverse of that ratio? The angle. All right, so our cosine, notice that's the way Google will put it. Okay, so 1 divided by root 5. 63.4349. So at that angle, the sine ratio is double the cosine ratio. Well, let's see if that's true. Let's test the sine ratio we got. Let's just go ahead and just test this. So again, I'm going to use the inverse here. And degrees is highlighted. And so we're going to see we should get the same thing when we do the sine of 2 divided by root 5. So the inverse sine. And then 2 divided by root 5. Oop, not 55. And notice it's the same.